Hello students, myself Nirlep Joshi. I welcome you all in the NV Science Academy. I hope you all are fine and you all like our videos. So please subscribe to our channel. Today we are going to study about the fundamental theorem of arithmetic from standard 10 mathematics. Let us see the fundamental theorem of arithmetic. The statement of the theorem is like: the prime factorization of a natural number is unique except for the order of its factors. It means you can change the order of the factors, but the factorization is always unique. So this is the fundamental theorem of arithmetic. As you can see, I am having one example. The number is 8550. That means it is 8550. The factors are 2 into 2 into 3 into 5 into 11 into 13. Okay, so these are the unique factors. You can change the order of the factors. Like I can also write down 8550 as 2 into 3 into 2 into 5 into 13 into 11, or I can write it down as 3 into 2 into 2 into 11 into 5 into 13. But the original idea remains same. The value will be not change. It is always 8550. Okay, and here you have to keep the word in mind that it is prime factorization. So now what is prime factorization? So that also I have mentioned here. The prime factorization, the process of writing a composite number as a product of primes. Okay, so we can write down the composite number as a product of primes. That is known as prime factorization. So I have written the same example again. I am having the number 8550, that is 2 into 2 into 3 into 5 into 11 into 13. Okay, now as you can see, these all are the prime numbers. Okay, these all are the 2, 3, 5, 11, 13. These all are the prime numbers. I have also mentioned here that what is prime number? The prime number is the number which is divisible only by itself and 1. The number which is divisible by only itself and 1 is known as the prime number. I have listed out some of the prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. Okay, so these all are the prime numbers and you can see these all are nothing but the prime numbers. So this is the fundamental theorem of arithmetic. Now the next topic is factor tree. So what is factor tree? It is nothing but the different method to write down the prime factorization of the natural number. I am having one number 8580. If I am going to write down the factorization, or you can say the prime factorization of this number in this manner, then this method is known as the factor tree. We are going to use this method in the next examples. Now the next topic is HCF, LCM and one equation. So what is HCF? HCF stands for highest common factor. So the HCF of two positive integers is defined as the product of the least power of each common prime factor involved in those numbers. Okay, I am having one example, 26 and 91. So how we are going to find out the HCF? So for that we have to write down the prime factors of the given number. So the prime factor of 26 is 13 multiplied by 2 and prime factor of 91 is 13 multiplied by 7. So here I am having 13 multiplied by 2 and 13 multiplied by 7. So how I am going to find out the HCF? So as it is written in the definition, that it is the least power of each common prime factor involved in those numbers. It means here in 26 I am having one prime number 13 and in 91 also I am having one prime number 13, and the least power, it means it is having right now one power, so I am going to consider the 1. Okay, for example, if it happens that here it is having 13 square multiplied by 7 for some number, okay, then also I'm going to use only 13. Okay, if it happen for some number that it is having 13 square multiplied by 7, then also I'm going to use only 13. I'm not going to use 13 square. Okay, so here the HCF of 26 and 91 is nothing but the 13. Okay, now second definition is about the LCM. LCM means least common multiple. So the LCM of two positive integers is defined as the product of the greatest power of each prime factor involved in those numbers. Okay, so here it is the greatest power. Okay, so in HCF it is least power, and in LCM it is the greatest power. Okay, so here I am having one example of two numbers. One is 510 and second is 92. So I am going to write down the prime factorization for 510. So 510 is equal to 2 multiplied by 3 multiplied by 5 multiplied by 17. So this is the prime factorization of 510, and prime factorization of 92 is 2 multiplied by 2 multiplied by 23. So it is 2 square multiplied by 23. Okay, so now how I am going to write down the LCM? So to write down the LCM, here I am going to use not 2 but 2 square, because the highest power of the prime factor involved, here the prime factor is 2, here also it is 2, but here the power is highest and it is 2 square. So I am going to use 2 square. So it is 2 square multiplied by 3 multiplied by 5 multiplied by 17 multiplied by 23. So we are going to multiply this, and the answer is nothing but the 23,460. So here this is the method by which we can find out the HCF and LCM. Here you have to remember one equation also, that if A and B are two positive integers, then HCF of AB multiplied by LCM of AB is equal to A multiplied by B. We are going to use this equation in the coming exercise. Let us start exercise 1.2, question number 1. So the question number 1 is express each number as a product of its prime factors. So here we are going to use factor tree method to find out the prime factors. They have given us 5 numbers. First is 140, second is 156, second is 3825, fourth is 5005, and fifth is 7429. So let us start with the first number. It is 140. So the first number is 140. Now here I am going to find out the prime factors. So first of all, see that 140 is, you can see it is even number, so we can divide it by 2. So I am going to divide it by 2. So what will be the answer? The answer will be 70. Okay, if you are not comfortable with this method, then you can do like this also. 140 and 2, we know the table of 2, so it is 2 sevens are 14, 0 0. For this 0 I have to put 1 0 in the above portion, so the answer is 70. So write down this 70 here and 2 here. Now 70, it is also again the even number, so again I will divide it by 2, so answer will be 35. Now 35 is not the even number, it is the odd number, so either I can divide it by 3 or by 5. Okay, so first of all I will check that I can divide it by 3 or not. If the sum of the number is divisible by 3, then you can say that number will be divisible by 3. Here the sum is 3 plus 5 is equal to 8, so it is not divisible by 3, so we are not going to divide it by 3, but we are going to divide it by 5. So 5, I know the table of 5, so 5 sevens are 35, so answer is 7. Now 7 is itself a prime number, so we can only divide 7 by 1. Okay, so here the prime factorization is like this. 140 is equal to 2 multiplied by 2 multiplied by 5 multiplied by 7. So I can write it down. Therefore 140 is equal to 2 square multiplied by 5 multiplied by 7. So this is the answer for the first question. So this is the prime factorization of 140. Okay, now let us see 156. Okay, here I can see that it is also the even number, so I am going to divide it by 2. When we divide this by 2, so what will be the remainder, what will be the answer? The answer is 78. Okay, so answer is 78. Now 78, again it is the even number, so we are going to divide it by 2. So what will be the answer? The answer is 39. Okay, now 39, it is not the even number, it is the odd number. So I'm going to check it that I can divide it by 3 or not. Okay, so it is 3 plus 9, 12. So I can divide 12 by 3. So I can also divide this 39 by 3. So 3, I know the table of 13. 13 3s are 39. So 13. Now 13 itself a prime number. So answer is like this 13, 1. So the prime factors of 156 is equal to 2 multiply by 2 multiply by 3 multiply by 13. Therefore 156 is equal to 2 square multiply by 3 multiply by 13. So this is the answer of 156. 3825. As you can see, it is not the even number, so we cannot divide this by 2. So now let us try with the 3. If the sum of this number is divisible by 3, then I can say that number will be divisible by 3. So 3 plus 8, 11, 11 plus 2, 13, 13 plus 5 is 18. So 18 is divisible by 3. It means I can divide this number by 3. So let us start with the 3. So 3. So 3 ones are 3. Okay. What will be the answer? The next number is 8. So 3 2s are 6, 22. So 3 7s are 21, 1. So 3 5s are 15. So 1275 is the answer. Again check 1275. 1 plus 2, 3. 3 plus 7, 10. 10 plus 5, 15. So again we can divide this number by 3. So 3. So 3 4s are 12. 3 2s are 6, 15. So 3 5s are 15. Now check again for 3. 4 plus 2, 6. 6 plus 5, 11. So we cannot divide this number by 3. Now we are going to divide this number by 5. So 5. What will be the answer? So I know that 8 5s are 40. So 25. So 8 5s are 5 5s are 25. Now 85. Again I can divide this by 5. So 5. So 5 ones are 5. 35. 5 17. 85. Okay. So here 17 itself a prime number. So it is 17 and 1. So the prime factorization of 3825 is equal to 3 multiply by 3 multiply by 5 multiply by 5 multiply by 17. Therefore 3825 is equal to 3 square multiply by 5 square multiply by 17. So this is the answer. The next is 5005. Here it is not even number, so I cannot divide it by 2. The sum of the number is not divisible by 3. So I am going to start with the 5. So 5. So answer will be 1001. Now how we are going to solve with 1001? For that I have to use the trial and error method. By using the trial and error method, I can find out that we can divide it by 7 and the remainder will be 143. Again I am going to divide 143. So it is 11 and 13. 13 itself a prime number. So the answer is 13 and 1. So the prime factorization of 5005 is 5 multiplied by 7 multiplied by 11 multiplied by 13. Therefore 5005. Okay, here no number is repeating, so we are not going to write down the second answer. Therefore 5005 is equal to 5 multiplied by 7 multiplied by 11 multiplied by 13. So this is the prime factorization of 5005. 7429. Here it is not even number, so there is no chance for 2. The sum is not divisible by 3, so there is no chance for 3. You can it is not having 5 or 0, so we cannot divide it by 5. So by using trial and error method, I have find out that we can divide it directly by 17, and 17 is itself a prime number, and the remainder is 437. Okay, so this you can find out by the trial and error method. Now the next division is 19 and 23. See here the first division is by 17, so there is no chance that you can find out that the next division will be by number less than 17. Okay, you have to try with the number more than 17. So I have tried with the 19 and I got the answer. It is 19 multiplied by 23. Here 23 itself a prime number, so answer is 23 and 1. So the prime factors of 7429 is 17 multiplied by 19 multiplied by 23. So here we have completed the first question of exercise 1.2. Now the second question of exercise 1.2. Find the LCM and HCF of the following pairs of integers and verify that LCM multiplied by HCF is equal to product of integers. This is the same equation that we have seen in the theory portion. They have given us three pairs. First is the 2691, second pair is 51092, and third pair is 336 and 54. So let us start with the first pair. The first pair is 26 and 91. So first we will find out the prime factors of 26 and 91, then we will find out the HCF, and then we will find out the LCM, and then we will find out the product. So for the 26, the prime factors of 26, it is 2 and 13 and 1. So the prime factors of 26 is 2 multiplied by 13. Okay, prime factorization of 91. So for 91 it is 7 and 13 1. So the prime factors of 91 is 7 multiplied by 13. Okay, from this what is the HCF? The HCF of 26 and 91 is equal to nothing but the 13. It is the least order of the common factor, so it is 13. Now about the LCM of 26 and 91, so it is a multiplication of highest order of common multiple as well as all the numbers. So here the multiplication will be like this: 2 multiplied by 7 multiplied by 13. Okay, so the answer is 182. Okay, so these are we have completed the half part. Now let us verify the equation of as given here. It is LCM multiplied by HCF is equal to product of two integers. So first of all we are going to find out the multiplication of HCF and LCM, and then we are going to find out the multiplication or the product of 26 and 91. So HCF of 26 and 91 multiplied by LCM of 26 and 91, so is equal to 13 multiplied by 182. So the answer is 2366. So the answer is 2366, and the product of 26 and 91 is equal to it also 2366. So here we can say that it verifies the equation LCM multiplied by HCF is equal to product of integers. For the second pair, 510 and 92, so the prime factorization of 510 is 2 multiplied by 3 multiplied by 5 multiplied by 17. You can see we can divide 510 by 2, so answer is 255. We are going to divide 255 by 3, so answer is 85. We are going to divide this 85 by 5, so answer is 17. 17 itself a prime number, so here answer is completed, and the answer is 2 multiplied by 3 multiplied by 5 multiplied by 17. Same way for 92, the prime factors are 2, 2 and 23. Okay, first of all the LCM of 510 and 92 is 2 square multiplied by 3 multiplied by 5 multiplied by 17 multiplied by 23. So the answer is 23,460. Okay, the HCF of 510 and 92 is 2. It is the least power, and for the LCM it is the greatest power. Okay, so here it is the highest common factor, it is 2 only. Here the 2 is only common factor. Now HCF multiplied by LCM is equal to 23,460 460 multiplied by 2 is equal to 46,920. If you multiply this 510 and 92, then you will get the same answer, that is 46,920. So here we have verified the given equation that LCM multiplied by HCF is equal to product of integers. For the third pair, that is 336 and 54. So for 336, the prime factorization is 2, 168, 284, 242, 221, 37 and 71. So the prime factors are 2 raised to 4 multiplied by 3 multiplied by 7. Now 2 raised to 4, it means it is 2 multiplied by 2 multiplied by 2 multiplied by 2. So it is 2 raised to 4. So 2 raised to 4 multiplied by 3 multiplied by 7, that is the prime factorization for 336. For 54, the prime factorization is 2 into 3 cube. So how it is 2 into 3 cube? So 54, if we divide it by 2, so answer is 27. 27 divisible by 3, 9, 3, 3, 3, 1. So the answer is 2 into 3 into 3 into 3. That means this is 3 cube. Now the LCM of 336 and 54 is 2 raised to 4 multiplied by 3 cube multiplied by 7. Okay, so it is 2 raised to 4 multiplied by 3 cube multiplied by 7 is equal to 3024. Now the HCF is the common common factors with the least power. So it is 2 into 3. So it is 2 into 3. Okay, so we are going to use 2 and 3. So 2 multiplied by 3 is equal to 6. Now LCM multiplied by HCF is equal to 3024 multiplied by 6. So it is 18,144. And for the product of the number 336 multiplied by 54, it is also 18,144. So by this we have verified the given equation. Here we have completed first two questions of exercise 1.2. In the next session we are going to see more theories and the next questions of exercise 1.2. Till then, please keep watching the videos and keep subscribing our channel. You can also follow us on Instagram and our Facebook page. Thank you.